The password is the same, guys. Uppercase S O O M 1234. Click on start. Here you find DNS, or you can also go from administrative tools to DNS. Yeah, in this way, one and the same. And here in the forward lookup zone, you find zoom.com, and on the right hand side, these are your host A records. And how to create a host A record here? In this way. As you find this ESXi1, this is the host A record for my ESXi 10.0.1.20, ESXi2 host A record 10.0.1.30. You want to create a host A record, right click in this empty area and click on new host and give the name, host name which you have assigned to your ESXi. For example, ESXi1 Prabhakar or ESXi1 Rupesh, and then give the IP address what you have configured. Okay, and click on add host, and the host A record will be created. Clear? Clear, guys? All you need to do is expand this in the empty area, right click on new host, give the host name, mention the IP address, and click on add host, and your job is done. That's it. Clear? So this is how you create a host A record on your DNS server. Fine? Alright, now we have seen the practical of virtual machine. However, what is a virtual machine from the perspective of ESXi, guys? It is nothing but set of files stored in a folder, and that folder is on my data store. If you see this, right now, online-ESXi1-Prabhakar is my virtual machine, and it is stored on data store 1. If I browse this data store, right click the data store and click on browse, you find the folder with that particular name. Here, ESXi, online ESXi1-Prabhakar1. This is the folder. Virtual machine set of files stored in a folder. If you click on folder, you find the files associated with this virtual machine. Okay, let us discuss the theory of virtual machine. What are the files associated with this virtual machine, and what does this file mean? What does this file mean? What does this file mean? So on and so forth. Okay, so let us try to understand that. We have seen the practical, but not the theory of virtual machine. Let us see that. Guys, what is a virtual machine? VMware calls it as set of discrete files. From the perspective of operating system, it is nothing but set of virtual hardware, and supported operating system can be installed on it. Okay. Now let us see what are the files associated with virtual machine. The most important file here has an extension .vmx file. Now this is the configuration file of your virtual machine. What are the configuration? And got two cores to your virtual machine. You configure RAM to it, maybe 2 GB, 4 GB, 6 GB. Then you configure the virtual hard disk, then the NIC card. All this configuration, the hardware configuration information of this virtual machine is stored in this particular file called configuration file, which has an extension .vmx. The most important file, guys, if this file is missing, then your virtual machine will not get powered on. So configuration file, which has an extension file of a virtual machine .vmdk. Now .vmdk is nothing but the virtual hard disk of your virtual machine. What is the meaning of it? That when you create a virtual machine and you create a virtual hard disk, that virtual hard disk is nothing but a file ESXi. But when you install your operating system, and what is the file system we are going to use to format this virtual hard disk?
No,
what is the file system we are going to use to format this virtual hard disk?
VM5.
If I am installing
NTFS or pattern?
Yep. Now try to understand this. Now this is the virtual hard disk of your virtual machine, and this virtual hard disk, no doubt, it is a file to ESXi, but it is a hard disk to your operating system getting installed, and your operating system is going to format this hard disk with the respective file system. If you are installing Windows, it formats that with NTFS or FAT. If you are installing Linux with ext2, ext3, or ext4, if you are installing ESXi, then it's going to format this virtual hard disk with VM5 file system, which I'm going to install of the respective to the operating system which I'm going to install. Okay. However, there are two files associated with virtual hard disk. The first file, which has an extension .vmdk. Now this is called the disk descriptive file or disk descriptor file, and there is another file associated with virtual disk. This is called the disk data file. That means the actual data of your virtual machine's guest operating system. Like for example, your guest operating system getting installed. The data is on -flat.vmdk. Your applications which are getting installed on your guest operating system could be on -flat.vmdk. So there are two files associated with your virtual hard disk. One is .vmdk, which is the disk descriptor file, and the other one is called two files associated with .vmdk. Now, guys, as virtual machine is functionally equal to a physical machine requires a BIOS to boot. In the same way, virtual machine also requires a BIOS to boot. Now, the BIOS file, virtual machine's BIOS file, will have the extension .nvram. So, .nvram is the virtual machine's BIOS file. Then you find a file associated with virtual machine log file, which has an extension .log. Now this is the virtual machine's current log file. There might be multiple log files like log 1, log 2, log 3 inside the folder of the virtual machine, but .log would be the virtual machine's current log file. In the same way, there is another file in the virtual machine's folder which is having an extension .vswp. Now this is the swap file of your virtual machine. All right. Now till .vswp, machines will have these files from VMX to .vswp. But these files like .vmsd, .vmsn, until -rdm.vmdk, these files gets created as you perform a certain task on your virtual machine. For example, these three files, .vmsd, which is called as snapshot descriptive file, is created when you create a snapshot on a virtual machine. Now, what is a snapshot? I'll explain that in a moment. And there are three files associated with the snapshot: .vmsd, .vmsn, which is the snapshot state file, and -delta.vmdk, which is called as snapshot disk file. Now, what is a snapshot? Now, guys, this functionality is available on a virtual machine. You can create a snapshot. Snapshot is nothing but an image. Now, when you create a snapshot, what ESXi is going to do is that it is going to capture the present state information of that virtual machine and store that in the form of a file, which is called a snapshot file. Now, why we are going to use snapshots? Now, snapshots are working as temporary backup solutions, as emergency backup solutions. Now, your operating systems which are running on top of your virtual machines will require patching from time to time. And let us say you are installing a patch to your operating system, or you are installing a patch to your application which is running on top of it. And we don't know that after the installation of patch, how my operating system or application is going to behave. Sometimes my operating system may get corrupted because of that particular patch. Sometimes my application may get corrupted because of that particular patch. And if that happens, then if you go with normal backup solutions, then it will take a lot of time for you to recover that, whether your operating system or the application. So here comes Snapshot, a handy tool for emergency backup solutions. Prior to applying a patch on your operating system or your application, I can create a snapshot. Now the snapshot will capture the present state information of that entire virtual machine and store that in the form of a file. And after that, you install the patch and something goes wrong, need not worry. You can just revert back to the snapshot file and you're back up and running within a couple of minutes. So guys, why I'm telling that snapshot is a temporary backup solution, not a permanent backup solution, because all these files associated with snapshots are getting stored in the same folder of your virtual machine. See here guys, this is my folder of my virtual machine. If I create a snapshot, then that snapshot file would be on the same folder. That means would be inside this folder only. Okay, fine. So what is going to happen? Why I'm telling this as a temporary backup solution is because if I delete this virtual machine, let us say, if I delete this virtual machine, then that particular folder will get deleted, and the snapshots which are acting as backup solutions will also get deleted. So that's the reason why it is not a permanent backup solution. For permanent backup, we are going to use other tools to back up our virtual machine, like for example VDP. Fine. That is why snapshots are used. And when you create a snapshot, these are the files which are created. These three files: snapshot descriptive file, snapshot state file, and snapshot disk file. Now, there is another option, or there is another feature available in vSphere where we can create templates out of virtual machines. Now, using these templates, uh, we can create multiple virtual machines, identical virtual machines. Now, how templates come handy to you as a VMware administrator? Now, let us say that you are a VMware administrator and there is a new project which is coming in your virtual infrastructure, and that new project requires 50 new machines to be created with Windows or Linux as an operating system, and maybe a specific application installed on it. Now, you as a VMware administrator, if you have to create these 50 virtual machines, then if you want to do this task manually, then you have to create virtual machines, like right click a new virtual machine, right click on new virtual machine, and you have to configure these virtual machines with all the configurations, like custom, click on next, give a new virtual machine name, so on and so forth. So you need to create a new virtual machine, then install an operating system on it, then install an application. So if you go ahead with this manual task, then each virtual machine for the creation will take at least half an hour. The creation, the installation of operating system, and the installation of the application. It may consume a lot of time. Rather than doing that, what I can do is that I can create one virtual machine, create a template out of it, and using that template, I can deploy the remaining virtual machines. So in real time, what we do is that for every operating system, for example, in my infrastructure, I use Windows 2003, 2008, 2012, Linux RHEL5, RHEL6, maybe RHEL4. In that way, XP, Windows 7, Windows 8. So there might be requirement in my infrastructure to create these type of virtual machines again and again. So what I do is that for every operating system, I create a template. I create a template. So whenever there is a requirement for me to deploy 10 virtual machines with Windows 7, I can use the template of Windows 7 and deploy 10 virtual machines. For example, there is a requirement for me to have 20 virtual machines with Microsoft 2003 or 2008 server, or because you might be configuring certain applications on it. Using the template of Windows Server 2003, you can deploy 10 or 20 new virtual machines. So this is how templates are going to be used. So when you create a template is nothing but a master image copy of a virtual machine. So when you create a template, this particular file gets created, which has an extension .vmtx. This is the template file. Okay. Now, guys, 99.99% your virtual machine has the virtual hardware, and specifically I'm talking about the virtual hard disk here. 99% your virtual machine has virtual hard disk. Okay. Sometimes, however, your virtual machine may be required to access a physical drive directly, most probably a physical LAN directly. Why there would be a requirement for virtual machine to access a physical LAN directly? There might be certain applications which are running on top of your virtual machine, and those applications require a lot of read and write operations. Why? Because maybe it is an important database, and that important database will include a lot of read and write operations. And you think that virtual hard disk will not meet that requirement of read and write operations. So you want this virtual hard disk to access a physical LAN directly so that you can install this database on the physical LAN. So that can be configured using RDM, which is called as raw device mapping. So by using RDM, raw device mapping, I can give a virtual machine access to a physical LAN directly. So this file -rdm.vmdk, which is the raw device map file, is going to get created only when you configure a virtual machine to access a physical LAN directly. Okay. So these are the files associated with virtual machine, and all these files would be stored in the same folder of a virtual machine. There are certain files which are available on every virtual machine, but there are certain files which are created when you perform certain tasks like snapshot, template, and raw device mapping. Now, when your virtual machine can also be stored on NAS boxes. For example, you are storing your virtual machine on NAS. There might be an additional log file if you're storing your virtual machine on NAS. And we take the backup of our virtual machines using the tools like VDP, VDR. VDR stands for vSphere Data Recovery. This was used till 5.0. From 5.1 onwards, we are using vSphere Data Protection. Okay. Now, if you are backing up your virtual machine using VDP or VDR, there might be an extra file which is called as change tracking file in the same folder which forms your virtual machine. So you need not worry, I'm going to discuss this change tracking file in detail when I discuss VDP. However, there are certain files available on each and every virtual machine, but there are certain files which are created when you perform a certain task on it. Clear, guys? Any doubts with these files before I move ahead?
Just can you come again, please? Like I was missed the whole topic. I was disconnected from this class and I just joined. So just give me like what are the notes, please?
See, guys, virtual machine is nothing but set of files. Okay, those set of files are stored in a folder. So when you create a virtual machine, there are certain files which are created. For example, .vmx file is the configuration file of your virtual machine, which will hold the configuration information of your virtual machine. Then you find the .vmdk, which is your virtual hard disk, the disk descriptor file. And there is another file associated with your virtual hard disk, -flag.vmdk. This is disk data file. So when you install the operating system and application, all those operating system and applications are getting stored on -flag.vmdk. This is the file which holds the data. And virtual machine functionally equal to a physical machine. Physical machine has BIOS in the same way virtual machine also has a BIOS, and that BIOS is in the form of a file here. .nvram is the BIOS file. The .log, it is the log file of your virtual machine, and this is the current log file. And your virtual machine may have multiple log files like log1, log2, log3 in that way. But however, the extension file .log is the current log file. And there is another file which is the swap file of your virtual machine, which is .vswp. Okay. Now till here, almost all the virtual machines will have these files, but there are certain files which are created when you perform certain tasks. For example, a snapshot. When you create a snapshot, these three files will get created. .vmsd, snapshot descriptive file, .vmsn, snapshot state file, and -delta.vmdk, which is the snapshot disk file. So these files are created when you create a snapshot. And when you create a template, then this particular file gets created, which is .vmpx, which is the template file. And a raw device mapping file, this file is created when you give a virtual machine direct access to a physical LAN. So -rdm.vmdk is the raw device mapping file. And there might be certain other files as well associated with virtual machine. For example, if you're storing your virtual machine on NAS, then there might be an additional log file if you're storing your virtual machine on NAS. And another file may be also available inside the folder of your virtual machine, like change tracking file, if you back your virtual machine using VDR or VDP. So these are the files which are associated with your virtual machine. Clear? All right. Now let us move forward from here. Okay. Now virtual machine is nothing but set of hardware, virtual hardware. Now these are the virtual hardwares available to your virtual machine. So your virtual machine can have up to 64 virtual CPUs. Guys, this depends on three things. The first one is vSphere licensing. If your vSphere license is Enterprise Plus, then only you can get 64 virtual CPUs to your virtual machines, if not more. Second, your physical server should have 64 cores or logical processors. Then only your virtual machine can get 64 virtual CPUs. Third, the guest operating system getting installed on top of your virtual machine needs to support 64 CPUs. Then only your virtual machine can get 64 virtual CPUs. So if your virtual machine wants to utilize 64 virtual CPUs, then these three criteria has to be met. First one, you need to have Enterprise Plus licensing. Second, on the motherboard of your server where your ESXi is running, that motherboard needs to have at least 64 cores or 64 logical processors. Then the third one, the operating system getting installed on top of the virtual machine needs to support up to 64 virtual CPUs. Now, for example, XP doesn't support 64 virtual CPUs. It supports only 2 CPUs. So let us say first criteria of the enterprise licensing is available. Second criteria, the server also has 64 cores. Because so it's on the one. Have up to on this depends machine hardware version, which depends the vSphere version you are using. For example, machine cannot get up to 1 terabyte, you can get only 255 GB. So from hardware version 8 onwards, your virtual machine can get up to 1 terabyte RAM. So this depends on the virtual machine hardware version. And second, your host on the physical server, you need to have 1 terabyte RAM. So it depends on two things, guys. Clear? Any confusion with the CPUs and the RAM? Yes. Sure. Sure. Guys, the 1 terabyte RAM, your virtual machine can use up to 1 terabyte RAM. However, this depends on the virtual machine hardware version. Now, that virtual machine hardware version is depending on the vSphere version. Now, for example, vSphere 4, the virtual machines on vSphere 4 will have virtual machine hardware version 4. vSphere 4.1 will have virtual machine hardware version 7. From vSphere 5 onwards, vSphere 5 has virtual machine hardware version 8, and vSphere 5.1 has virtual machine hardware version 9. So this 1 terabyte support is only available from vSphere 5 onwards. Okay. So if you have vSphere 4.1, then the virtual machines on vSphere 4.1 cannot get up to 1 terabyte RAM. They can get only up to 255 GB. Okay. So this depends on the virtual machine hardware version, which is directly depending on the vSphere version. Second, the physical RAM should be available. That means your ESXi host should have 1 terabyte RAM. Then only your virtual machine can get 1 terabyte. If your physical host only has 32 GB, then you cannot configure or you cannot give 1 terabyte RAM to your virtual machine. Clear? Clear? Now, yep, you're welcome. Now, up to 10 NICs. Your virtual machines can have up to 10 virtual NIC cards, and you can have 4 SCSI adapters. Guys, the SCSI adapters, these are the storage adapters basically, where your virtual disks are going to get connected. So four SCSI adapters, each SCSI adapter can have 15 devices. So if you calculate 15 into 4, 60. So 60 virtual hard disks can be connected to your virtual machine. That is the meaning of it. Okay, and you have ID controller. Four devices can be connected. One USB controller, 20 devices, three parallel ports, four COM ports or serial ports, one floppy controller. And my virtual machine also supports high definition audio, HD audio, and my virtual machine also supports 3D graphics. And here, my virtual machine supports only NVIDIA graphics, guys. It doesn't support Intel and AMD. And obviously a keyboard and a mouse. So these are your hardware available for your virtual machine. However, sometimes your virtual machine needs to access a physical device directly. Normally, virtual machines utilize virtual hardware, okay, but sometimes your virtual machines need to access a physical device directly. That too specifically a physical device which is available on your PCI slot on your motherboard of your server. So if that's the case, then VMware has this technology called vSphere Direct Path Technology. Using vSphere Direct Path Technology, your virtual machine can access up to six PCI devices directly. That means up to six PCI physical devices can be accessed by your virtual machine directly using vSphere Direct Path Technology. Okay, and let me give you an idea why there is a requirement for your virtual machine to access this PCI device directly. There might be certain applications running on top of your virtual machine's guest operating system. For example, telecom applications, and those telecom applications may require a telecom card, a telecom device, which gets fixed on your motherboard's PCI slot or PCI slot. So if that application has to function inside your virtual machine, then it needs to access that physical device. Now, if that's the case, then you can use this vSphere Direct Path technology. Using this technology, your virtual machine can access the PCI device directly. Clear? Right, now let's move forward. Now guys, this is what I have mentioned about maximum CPUs up to 64 CPUs. This depends on the number of CPUs available on the host and the number of CPUs the guest operating system supports. And guys, your operating system utilizing multiple CPUs is called as symmetric multiprocessing. And as virtual machine can also use multiple CPUs, this technology is called as VSMP or virtual symmetric multiprocessing or VMware vSphere virtual symmetric multiprocessing. What is that? It's nothing but configuring a VM with multiple virtual CPUs. Okay. Now up to 1 TB RAM, the virtual machine can use. This depends on the amount of RAM configured on the virtual machine and the maximum amount of physical memory a virtual machine can use. This we have already discussed. Now, this is important, guys. Let us try to understand this. Guys, my virtual machines, 99.99% or 99% will have virtual hard disk. And when you create a virtual machine, when you reach the place where you have to create a new virtual hard disk, the virtual hard disks are of, or the virtual hard disks are broadly classified into two types. Okay, one is thick provision hard disk, the other one is thin provision hard disk. So we'll discuss that and we'll try to understand what is this. Let us say this is ESXi, and on top of it, let me say that I'm creating virtual machines. This is my VM1, this is VM2, VM3, and VM4. Let us say, okay, and this is VM1, 2, 3, and 4. Now, what is a virtual machine from the perspective of ESXi? It is nothing but set of files stored in a folder, and that folder is getting stored on my local hard disk or on my SAN. Let us say my virtual machine is getting stored on my SAN. All right. On my SAN, let us say I have two LUNs. Each LUN is of a size of 100 GB. So I'll format these LUNs with VMFS and they'll become VMFS data stores. Let us say this is my VMFS1. Let us say this is VMFS1, which has a capacity of approximately, let us say 100 GB. GB is my VMFS1. And the second one is VMFS2, which is of 100 GB. Okay. Now, let us talk about this. Okay. Now, virtual hard disks and virtual hard disks get connected to virtual SCSI adapters, and your virtual machines can have these four types of adapters, guys: bus logic parallel, LSA logic parallel, LSA logic SAS, and VMware para virtual. Now, these three adapters, bus logic parallel, LSA logic parallel, and LSA logic SAS, are nothing but the emulated version of SCSI adapters available on your physical servers. Whenever you go and purchase a physical server, that physical server will have either one of the adapter, SCSI adapter like bus logic parallel adapter, LSA logic parallel, or LSA logic SAS adapter. Fine. Now, what VMware has done is that they have created an emulated version of these physical adapters, and you have this virtual SCSI adapters. In the same way, VMware has created its own VMware para virtual adapter. Now, this adapter is used for certain operating systems when you install to get connected to a virtual hard disk. Now, then the types of virtual disks which your virtual machine can have. You have thick provision, lazy zeroed, thick provision, eager zeroed, and thin provisioning. First, we'll try to understand the difference between thick and thin. Then we'll try to understand the difference between thick, lazy zeroed, and thick, eager zeroed. Now, let us say that I'm creating a virtual machine number one, and I've reached a place where I need to create a virtual hard disk for this virtual machine. Let us say I'm creating a virtual hard disk of 40 GB. Okay. Now, where is this 40 GB space coming from? I'm storing this virtual machine, let us say, on VMFS1. This 40 GB space for my virtual hard disk is coming from this 100 GB space. Okay. So if I create a virtual hard disk of 40 GB and the provision is thick, what is the provision here? Try to understand. It is thick provision. Okay. If it is thick provision, then what VMFS is going to do is that it is going to allocate 40 GB to my virtual machine from this 100 GB. So what is going to happen? Out of this 100 GB, 40 GB is allocated to VM1, to the virtual hard disk. So what is the remaining space available? 60 GB. Okay. So if you go with thick provisioning, the allocation of that space is allocated to the virtual machine from the data store space. My data store space is right now 100 GB. I have created a virtual machine, virtual hard disk with thick provisioning. Thick provisioning means allocation is done. So out of 100 GB, 40 GB is given to my virtual machine number one. Now let us say I'm creating a virtual machine number two, and this time I'm creating the virtual hard disk of my virtual machine number two, and I'm going to configure 60 GB, and that too thick. So I told you, if you go with thick provisioning, the space is allocated to the virtual machine from the data store space. Now on my VMFS1, I have only 60 GB available. So entire 60 GB would be allocated to this virtual machine number two. So minus 60 GB, I don't have any more space available. Why? Because the entire space has been consumed by VM1 and VM2. Why? Because that 40 GB and 60 GB has been allocated to VM1 and VM2 respectively. Now here we'll try to understand that VM1 has been allocated 40 GB space. Why? Because its virtual hard disk is 40 GB. Now whether VM1 utilizes that entire 40 GB or not, but that entire 40 GB has been allocated from the data store space. So that means allocation is done, and now on VMFS1 I don't have any more space available. Why? Because it has been allocated to my virtual machine number one and virtual machine number two. So here VM1 and VM2 has occupied the entire space. I don't have any more space available to store my virtual machines on VMFS1. Now let us say there is another data store called VMFS2, okay, which has a capacity of again 100 GB. All right, and this time I'm creating a third virtual machine number 3. And now when I create a virtual hard disk of this virtual machine, I go with configuration of 40 GB, and this time I'll go with thin provisioning. When I go and configure a virtual hard disk with thin provisioning means commitment is done, but allocation is not done. Guys, commitment is something which is a promise for the future. That means I'm promising that virtual machine number 3 is going to get 40 GB whenever it requires, but I'm not allocating the space right now. Suppose 40 GB, that is what I committed to my virtual machine number 3. Why? Because its virtual hard disk is 40 GB. But out of the 40 GB, let us say that virtual machine number 3 is only utilizing 4 GB. So 4 GB would be allocated to it. The remaining space is still available. So 100 GB minus 4 GB, the remaining space is 96 GB. Fine. Now let us say I'm creating a virtual machine number 4, and here I have configured the virtual hard disk size of 80 GB, and this time I'm going with thin provisioning. What is thin provisioning? Only commitment. So out of this 96 GB, I'm committing that I'm going to provide 80 GB to my virtual machine number 4 whenever required. Okay, but out of that 80 GB, let us say virtual machine number 4 is utilizing only 10 GB. So 10 GB is allocated to it. So the remaining space is 86 GB free space available on my VMFS 2. Now let us say I create another virtual machine, okay, which is my VM5 on my ESXi host. And now I'm creating a virtual hard disk to VM5, and this time I'm configuring 100 GB. Okay, and this time I've selected thin provisioning 100 GB. What is the meaning of thin provisioning? No allocation, but only commitment. Where I'm storing this VM5? On this VMFS shared 2, VMFS 2. So this is VM3 here. I've also stored my VM4. Now I'm storing my VM5. Now VM5 virtual hard disk is 100 GB. What is the actual amount of space available on my data store? Only 86 GB. Only 86 GB, but I'm committing I'm going to give 100 GB. Why? Because thin provisioning means only commitment, no allocation. So I can store a virtual machine, virtual hard disk of 100 GB on an 86 GB data store as well. So here, let us say that this VM5 is utilizing only 10 GB of it. So 10 GB would be removed, okay, and the remaining space which is available would be 76 GB, still free space available. So this is how actually thin provisioning works, where with thin provisioning, if you see this right now, you have virtual machine number 3, 4 and 5. If you put all together, what is the space? 100 plus 80, 180 plus 40 is 220, but whereas the actual space I have on my data store is only 100 GB. So using thin provisioning, I can overcommit my storage. What is the advantage of it? That I can optimally utilize my storage, guys. However, keep this in mind, sometimes if your virtual machines require the actual space and your data store will not be able to provide that actual space. Why? Because here actually I have only 100 GB, but I have overcommitted almost 120 GB extra. So this is thin provisioning. Guys, did you understand the difference between thin and thick? Guys, if you go with thick provisioning, allocation is done. If you go with thin provisioning, commitment is done, allocation is done as demanded by the virtual machine. Clear with the concept of thin and thick? Okay, it depends. Yes, it depends on what type of application you are running on top of your virtual machine's guest operating system. Okay, suppose it depends. Okay, now let me give you a scenario. Suppose you are running a database. Okay, suppose you are running a database on top of your virtual machine, and you know that your database consumes a lot of space, and that space consumption would be quite high, and maybe very fast your database is going to be filled with data. If you think that is the case, then better go with thick rather than going with thin. And there might be certain applications which don't require space. Why? Because data is not expanded. Usually the data is normally the same. If that's the case, then go with thin provisioning. For example, if you are running a DHCP server inside your virtual machine, now DHCP server's data is not that widely expanded. Maybe you can go with thin provisioning for those type of applications. Maybe you can also go with for DNS server. If you're configuring DNS server and running DNS application, DNS service on top of your virtual machine. You can go with thin provisioning for these kind of applications or services. For example, you are running an important database and you think that database is going to expand a lot and it requires a lot of space, and better to go with thick provisioning rather than going with thin. So it depends on application, what type of application you are using. And if you're running a database and you think that that database is not going to be filled for a very long period of time and only it's a database, maybe it is not expanding that dynamically, then you can even go with thin provisioning for those kind of applications. So it depends on an application. Based on it, you need to go and configure thin and thick, whether production or it is non-production. Yeah? Yeah? Right. Your voice is breaking. Could you repeat your question again? No. Try to understand this. The virtual hard disk is nothing but a file, and that file is getting stored on my VMFS partition. Okay. Now, after you create a virtual machine, you install the operating system, right, on top of your virtual machine. Now that virtual hard disk is nothing but a file from the perspective of ESXi, but operating system is looking towards it as it appears as a hard disk to it. So it is going to format that hard disk with the respective operating system which is getting installed. Suppose I'm installing Windows as an operating system on my virtual machine, then my virtual hard disk is going to get formatted with FAT or NTFS. If I'm installing Linux, then my virtual hard disk is going to format it with ext2, ext3, or ext4. So the format of the virtual hard disk depends on the operating system which is getting installed. Yeah. Fine. Any other question apart from this? Clear with thick and thin, guys? In thick, just keep in mind, allocation is done from the data store. In thin, only commitment is done, allocation is done as demanded by the virtual machine. Yeah. So with thin provisioning, we can overcommit the data, storage space, and we can run multiple virtual machines on our data stores with thin provisioning. Okay. Fine. Now let us try to understand the difference between thick provision lazy zeroed and thick provision eager zeroed. Now here, guys, the name lazy, who are lazy guys who postpone the things for tomorrow. For example, I'm a lazy guy. I want to postpone the things for tomorrow. So, all right, the lighter side, kids kidding apart. Fine. Now lazy zeroed here, guys. Normally, guys, when a virtual hard disk is created, in the background there might be certain data which has to be scratched out, which has to be removed. Okay, and this particular scratching of the data in the background is called as filling the hard disk with zeros. Okay, you can fill the entire hard disk with zeros. So this filling out of the hard disk with zeros, if you go and configure thick provision lazy zeroed, is going to occur after the creation of the virtual hard disk. Now, if you go and configure a virtual hard disk with thick provision eager zeroed, now the filling out of the hard disk with zeros is going to occur during the creation itself. So the entire hard disk gets filled with zeros during the creation if you go with thick provision eager zeroed. So if you create a virtual hard disk with thick provision eager zeroed, it will take time for creation because in the background the entire data is being scratched out by filling out the entire hard disk with zeros. So eager zeroed hard disk will take time for creation because the filling out of the zeros is occurred during the creation itself. Whereas the lazy zeroed, the filling out of the zeros will occur after the creation and when the first read and write operations occurs on the virtual hard disk. At that particular time, the filling out of the zeros will start. But with eager zeroed, it is created during the creation itself, the filling out of the hard disk is done. So, guys, if you want to configure fault tolerance, there is a concept of fault tolerance in our vSphere infrastructure. If you configure fault tolerance, then your virtual machine would be available 24/7 even in the case of ESXi failure. So fault tolerance, if you want to configure fault tolerance on a virtual machine, then your virtual machine's virtual hard disk should be thick provision eager zero. Thick provision eager zero. If not, you can go with thick lazy zeroed as well, not a problem. But for fault tolerance virtual machines, thick provision eager zeroed is absolutely required. All right. Let me move forward. Now, we have seen the CPU part. How many CPUs can be configured to our virtual machine? How much RAM can be configured to our virtual machine? We have seen what type of virtual hardware my virtual machines can have. And now it is the time to discuss the NIC cards. My virtual machine has virtual hardware, and the most important component of a virtual machine when it comes to networking is the virtual NIC. Okay. Now my virtual machines will have virtual NIC, and my virtual NIC depends on the operating system which I am going to install. Now my virtual machines, virtual NICs are broadly classified into three types: flexible, the other one is E1000 or E1000E, and the third types are VMXNet2 and VMXNet3. Now, which virtual NIC is selected, or which virtual NIC is used inside your virtual machine? It depends on the operating system which you are going to install. So based on the operating system selection, the right virtual NIC card will be selected. For example, flexible. Flexible adapter or the flexible NIC card would be selected if you are going to install a 32-bit guest operating system. Guys, if you want to install a 32-bit guest operating system inside your virtual machine, then by default the selection is flexible. Now, in flexible, again, there are two types of adapters. The one is VLANs adapter, the other one is VMXNet adapter. Now, let me explain you when VLANs is used, when VMXNet is used. Whenever you configure a virtual machine with a 32-bit operating system, except Vista and later, however, okay, by default, it is going to take flexible. In flexible, it is going to take VLANs. VLANs adapter is nothing but an emulated version of AMD's adapter. If you want to see the exact model number of that AMD adapter, it is AMD 79C970 PCNet LANs adapter. Now, this is an emulated version of it, and for most of the 32-bit guest operating system, this is the selection during the creation. And after the installation of an operating system inside the virtual machine, we are going to install something called VMware Tools. I'm going to discuss the VMware Tools after this slide. But once you install VMware Tools, guys, that VLANs adapter gets converted into VMXNet adapter. Now, VMXNet adapter is a purely virtual adapter developed by VMware, and this is optimized for performance and functions only after the installation of VMware Tools. Okay, so first, during the installation of the guest operating system, if you have selected 32-bit, then let's now this 64-bit system, then the most operating systems for the default operating system would be E1000 or E1000E. Now, E1000 is an emulated version of Intel's gigabit card, and especially if you want to know the model number, it's 8254EM gigabit NIC card. It's an emulated version of it, and these drivers are available in XP and later guest operating systems, and from Linux 2.4.19 onwards, and it is default selection for almost 64-bit guest operating systems. Okay. And this is required for VLAN guest tagging support and all. And E1000E is also another emulated version of Intel AQ574L gigabit, and this is also a selection for 64-bit guest operating systems. And now, which one is selected? Whether E1000 or E1000E is selected? Now, this depends on the physical adapter available on your ESXi post. If your physical adapter functions as E1000, then your virtual machine is going to get E1000 as its adapter. If your physical adapter functions as E1000E, then your virtual machine is going to get E1000E if you select the 64-bit guest operating system. So this is about E1000 and E1000E. Then comes the other adapter, which is VMXNet2 adapter. This is a purely virtual adapter developed by VMware, and now this is based on VMXNet or the next generation of VMXNet adapter. Now, this adapter is selected for a few of the guest operating systems, and most probably Linux operating systems, and this provides better performance when compared to VMXNet adapter. It supports features like jumbo frames and hardware offloads. Hey, excuse me, guys. Okay, fine. So VMXNet2 would be the default selection for a few of the operating systems, especially certain Linux operating systems. and it is based on VMXNet or the second generation of VMXNet adapters. As I told you, for better performance and supports features like tempo frames and hardware output. And the third type of adapter, which is available, which can be available to your virtual machine, which is called as VMXNet 3 adapter. However, this is not related to VMXNet nor VMXNet 2. This is a different kind of adapter, and this adapter is available only from the virtual machines having the hardware version 7. That means from 4.1 vSphere 4.1 onwards, and it is supported by only limited guest operating systems, and it is a default selection for Red Hat Enterprise Linux 6. And what ID experts or we people say that it is better to go with this adapter if you're running Linux operating system 64-bit. If you're running 64-bit guest operating system Linux, then better to select or use VMXNet 3 when compared to E1000 or E1000E. And this is about VMXNet 3, guys. Okay, so you need not worry. Based on the operating system you select, the right adapter would be selected. But however, the only changes you can do is that if you are installing Red Hat Enterprise Linux or Linux 64-bit operating systems, my suggestion is that better to go with VMXNet 3 rather than going with E1000 or E1000E. However, for RHEL 6 by default, it selects VMXNet 3. For RHEL 5, it will take E1000, but I suggest you to change it to VMXNet 3. Clear, guys? Any doubts with the NIC cards? Any doubts with the NIC cards, guys? Yeah?
Clear.
Alright. Now, guys, before I deal with VMware tools, let me discuss very important point here. Okay, I'll ask you a question, please do answer. Guys, let us say I have my ESXi host here. Okay. Now I have my hardware. Now on top of it, I install my ESXi. Okay. Then what I do? I create virtual machines. And on top of the virtual machine, I install operating systems. Let's say, okay. Now, guys, my ESXi is getting installed on the hardware. Let me ask you a question. Guys, without having the right set of dash, my operating system will not be able to interact with the hardware. Fill in the blank. Yeah, without having the right set of dash, my operating system will not be able to interact with the hardware. What is that? What is that right set of?
Hardware? It's a...
No, guys, the kernel is the core component of an operating system.
ESXi.
No. Here, ESXi is my operating system, okay? Without having the right set of dash, my ESXi will not be able to interact with the hardware. What is the right set of?
Peripheral devices? So, the hardware, NIC
No, that is what hardware, right? That is the entire thing is my hardware. My motherboard, my processor, my RAM, my devices available on it, the NIC card. The entire thing is hardware. Yes, because those are nothing but device drivers, guys. Okay? Without having the right set of device drivers, my ESXi will not be able to interact with the hardware. Okay? Clear with the point? Guys, are device drivers operating system specific or are they independent?
OS specific.
Agreed? Fine. Now my ESXi is getting installed. We will have the right set of device drivers. Then it is going to interact with the hardware. Fine. This part is done. Okay. Now I created a virtual machine. On top of it, I am installing the operating system. Guys, are you able to hear my voice? Guys, are you able to hear the voice? Okay, are you able to see the screen as well? Fine.
Yes.
Now, on top of my virtual machine, I am installing the operating system. Let us say this is my Windows. Okay. Let us say I have installed Windows operating system. Now I'm asking you a question. Is there any requirement for me to install device drivers inside my operating system Windows associated with the actual hardware? Rupesh is saying yes, we need to install device drivers inside my operating system Windows associated with the actual hardware. What about others? Do you say yes, we need to install device drivers associated with the actual hardware? What about the others? Yes or no? Is there any requirement on my operating system Windows to install the device drivers associated with the actual hardware?
I think it's required to install any drivers
Okay, fine.
on Westvoice
Fine.
because it will take.
Okay, fine. Guys, I need not install any device drivers inside the operating system running on top of my virtual machine associated with the actual hardware. Okay, but actually, why there isn't requirement is because my operating system is running on my virtual machine. So from the perspective of operating system, what is a virtual machine, guys? What is a virtual machine? From the perspective of operating system, it's nothing but hardware. Am I right?
Hardware.
So here, my operating system is getting installed on my virtual machine. That is the virtual hardware. Okay. So I don't require the device drivers to get installed associated with the actual hardware, but I require the device drivers associated with the virtual hardware. Am I right? Right or wrong? Yes, guys. Am I right or wrong? Did you get my point? There is no requirement for my operating system, inside my operating system, to install device drivers associated with the actual hardware. Why? Because my operating system is getting installed on a virtual machine and my virtual machine has virtual hardware. But there is a requirement for me to install device drivers associated with virtual hardware. Am I right? Yes or no?
Yes.
Yes. We require device drivers. If there are no device drivers, operating systems cannot interact with the hardware. However, guys, here in VMware vSphere, when you create a virtual machine and install an operating system on it, there is no requirement for you to install any device drivers associated with the virtual hardware. However, guys, when you install Windows operating system on a physical machine, after the installation of operating system, what is the other thing you do? You install device drivers, right? Right or wrong? If you are installing Windows on a physical machine, do you install device drivers? Yes?
Yes, we install.
Yes, we install. But however, when you install Windows on a virtual machine of our vSphere, there is no need for you to install device drivers. Why? Why there isn't any need to install device drivers? Guys, operating system is nothing but collection of files. Am I right? It's collection of code. Now your operating systems has something called generic drivers inbuilt into it. The operating system installation will have certain drivers called generic drivers. Every operating system has these drivers, generic drivers. Okay. Now, what VMware has done is that VMware has intelligently created the virtual hardware of the virtual machine in such a way that whenever you install an operating system, that virtual hardware device drivers are already available in the installation of the operating system. So your operating system already has generic device drivers associated with that particular hardware. That's the reason why there is no need for you to install any device drivers. Now, how VMware has provided that hardware intelligently? That's the reason why, guys, when you create a virtual machine, your vSphere client wizard is going to ask you what is the operating system you are going to install, so that it can give the right hardware to that operating system, so that that operating system already has the generic drivers associated with that hardware, so that there isn't any requirement for you to install device drivers manually. Did you get the logic? Did you get the logic? That's the reason why when you create a virtual machine, it will ask you what is the operating system you want to install, so that it can provide the right hardware, so that your operating system already has the generic drivers associated with the hardware. Clear? That's the reason why when you install operating system on top of your virtual machines, there isn't any requirement for you to install device drivers separately, because there are generic drivers associated with that hardware inbuilt in your operating system. Clear with the concept, guys? Clear? However, after the installation of the guest operating system, the first thing you as a VMware administrator has to do is to install VMware tools. There is something called VMware tools. Now, guys, let me discuss what is VMware tools. Now, guys, VMware tools is nothing but suite of utilities. Okay, and how many people have used VMware Workstation? Anyone has used VMware Workstation? Okay, Rupesh is using it. What about the other guys? Have you used it? Guys, those who have used VMware Workstation, okay, or when you create a virtual machine on VMware vSphere and install Windows, you'll see certain things happening. Like, guys, after the installation of operating system, the display is not that good. The resolution is not that good. Okay, and you also might have observed that when you insert the mouse, when you click the mouse inside your virtual machine, your mouse gets locked inside the virtual machine's console, and you can come out of that particular cursor only by using the key Control Alt. Okay. Now all these types of problems will get resolved when you install VMware Tools. Why? Because VMware Tools installs many drivers, and let us see the features involved when you install VMware Tools. Guys, the first thing what VMware Tools does is that it replaces the generic drivers which were used to install the operating system and interact with the hardware during the installation with VMware drivers. The first thing what it does is that it replaces the generic drivers with VMware drivers. It also installs certain device drivers like SVGA display drivers. Because of it, after the installation of VMware Tools, the screen resolution, the resolution of your virtual machine's console will be better, and it also installs VMX.NET device drivers, because it's a purely virtual adapter, and it also installs certain device drivers like Balloon driver. Now, this Balloon driver I'll discuss in the resource management class, because it is used in memory management. There is also a driver called sync driver for squeezing of input-output operation. I'll discuss sync driver when I discuss vMotion concept, not to worry, and it will improve the mouse performance. There are certain other services also getting installed when you install VMware Tools. For example, VMware Heartbeat service. Now, this VMware Heartbeat service I'm going to discuss when I'm going to deal with the HA clusters. Why? Because this service helps the virtual machines to get rebooted by using this VMH Heartbeat service. I'm going to explain that in detail, not to worry. And there is another service which is called as VMware Tools service for time synchronization. I'm going to show you in a moment how to configure time synchronization on your ESXi host and virtual machines. And also, after the installation of VMware Tools, guys, the ability to shut down your virtual machine without entering into the console of the virtual machine, that is possible. Now, prior to the installation of VMware Tools, you cannot shut down the virtual machine unless and until you log in into the operating system. But once you install VMware Tools, you can shut down the virtual machine without logging into the operating system. And it also installs certain perfmon DLLs for monitoring inside the virtual machines, specifically running uh, Windows. It is only for Windows, guys. On Windows operating systems, when you install VMware tools, certain perfmon DLLs also get installed, which are used for monitoring. And from 5.1 onwards, guys, when you upgrade to newer versions of VMware tools, it requires less number of reboots, or sometimes no reboot is required if you're upgrading the new version of VMware tools. So VMware tools plays very important role, very critical for the virtual machines operations. That's the reason why the first thing you do after the creation of virtual machine and installing an operating system is to install VMware tools. I'll show you how to install VMware tools in a moment. Okay. So this is about VMware tools. Any doubt with VMware tools, guys? Any questions? Uh-huh. Uh-huh. Yes. Yes, absolutely. The OS has the inbuilt drivers, those are generic drivers, and that would get replaced with VMware drivers. Okay. Once install VMware tools. Fine. Anything else apart from that? Any other questions? Other guys? Clear? Is it clear? And very important, guys. VMware tools very important and critical for virtual machine operations, specifically in vMotion, specifically in memory management, specifically with HA cluster if you want to use the functionality of VM monitoring, and very important for time synchronization in our virtual infrastructure. So there are many things which are depending on VMware tools, and you as a VMware administrator, you need to install VMware tools after the installation of the guest operating system. So let me move forward and let me discuss what is a virtual appliance. We already discussed this in our first or second class. Now, virtual appliance is basically is nothing but a pre-configured virtual machine, guys, with a guest operating system and the required software or application installed. And this application or software might have been designed for a specific task like a firewall or a backup or recovery tool. Okay. Now, these type of pre-configured virtual machines are packaged using OVF. Okay. Now, it is also deployed in the form of OVF template. OVF stands for Open Virtualization format or Open Virtualization file. Now, OVF, Open Virtualization format, OVF was first developed by VMware, and later on the industry adapted it as a standard. Now, it is nothing but a platform independent open packaging and distribution format for virtual machines. So, someone wants to develop a solution for virtual infrastructure, and that solution runs as a virtual machine on your virtual infrastructure, so they can package it in the form of OVF. So OVF is platform independent. That means someone packages a virtual machine in the form of OVF, then this virtual machine can be deployed on any type of hypervisor, platform independent. And basically it was developed by VMware, later on adapted as a standard by the IT industry. So OVF, you can deploy this OVF, and once you deploy it, as it is a pre-configured virtual machine, you can just power on that virtual machine. There's already operating system and application running, and that application can work as a firewall, can also work as a backup tool, and we also know that vCenter server appliance, it's a virtual appliance basically. So VDP, which is vSphere data protection, which will work as backup and restore of your virtual machine. It is also a virtual appliance. So there are certain virtual appliances developed by VMware. You can download that from VMware Virtual Appliance Marketplace. And how to deploy this virtual appliances? You can use vSphere client and deploy it on vCenter server or on an ESXi host inventory directly. Okay. However, you're going to see how to deploy an OVF template in the class of VDP, why? Because VDP is a virtual appliance. All right. So keep this in mind. Virtual appliances are nothing but pre-configured virtual machines with an operating system installed and with a certain application running, and that certain application may be used for specific tasks like a firewall or a backup and recovery tool or utility. Yeah, clear, guys? So this was all about your virtual machines concepts. All right. Now let us see certain configurations which you have to do on your ESXi host and virtual machines, specifically the time configuration and so on and so forth. So So guys, this is my ESXi host. Okay. Now time plays very important role in any infrastructure, guys. Why time is important? Guys, many jobs depends on time. For example, backup jobs depends on time. And if you configure a backup job at that particular time, and on the backup server there is one particular time, and on the machine where you want to take the backup there is a different time, then the backup job will fail. Another important task for time is logging, guys, auditing. Logs are created, and if you have a wrong time configured on your machine, on your operating system, then most probably what is going to happen is that you are going to have wrong logs and will not be identify the problem and when this problem has occurred at which particular time, so on and so forth. Even for auditing, it is important. Time is important, and in many infrastructures, for example, in Active Directory, time plays very important role in authentication, so on and so forth. So it's very important. So in order to make sure that every machine in my infrastructure has common time or identical time, in real time we configure NTP. There might be NTP servers configured, and all the other servers would be pointed towards NTP server to get configured with the time. NTP stands for Network Time Protocol. And sometimes if you don't have an NTP, local NTP server configured, if you have internet access, then your servers can get synchronized with an online NTP server. So my ESXi can also be configured with NTP, and we need to configure NTP client on my ESXi host. In order to configure it, you need to use vSphere client and get connected to your ESXi host, and then go to the configuration tab. In the configuration tab, you find hardware and software section, and under the software, just go to time configuration here. And right now you can see this NTP client is stopped. If you want to configure your ESXi host as NTP client, then just click on property, and then you find this box which says NTP client enabled. Check this box, and then click on options, then click on NTP settings here, and now you can add the NTP servers. Suppose your infrastructure has a local NTP server, just mention the IP address or the FQDN, fully qualified domain name, and click on OK, and your ESXi host will get synchronized with this NTP server which is available locally. Suppose you don't have an NTP server locally available and your ESXi host has internet access, then you can also configure your ESXi to get configured with an online NTP server. There are many free online NTP servers, for example, pool.ntp.org. If you have this, if you configure the, and there are many NTP servers which are available for free. So you can configure any of the NTP server here and click on OK, and that's how your ESXi host is going to be configured with NTP server, so that there is time synchronization. So in your entire infrastructure, every ESXi host is configured with NTP client, so that they can be synchronized. They can synchronize time with our NTP server, and every machine in my infrastructure has equal time. Now this is the configuration on our ESXi. But what about the virtual machines? Why? Because virtual machines times also is important. Why? Because the applications and the services are running on top of our virtual machines. So how to configure NTP on the virtual machines? Guys, individually you need to configure NTP from the perspective of the guest operating systems running inside the virtual machines. However, as we have VMware tools installed on our virtual machines, then we can easily synchronize the guest operating system time with our host time by using VMware tools. So on each and every virtual machine, if you do one configuration, and that configuration will synchronize the guest time with the host. For example, right-click the virtual machine, click on Edit Settings, and here you find three tabs. The first one is Hardware, second one is Options. Click on Options, and here in the Options settings you find VMware Tools. And once you click on VMware Tools, on the right-hand side you find certain options. Under Advanced, you find this option which says Synchronize guest time with host. If you check this option, then this virtual machine will synchronize the time with the host. So if you check this box on all the virtual machines, then all the virtual machines on the particular host will get synchronized, and we'll make sure that every virtual machine and host has equal time in our infrastructure. So this is how we configure ESXi host with time synchronization, and this is how we synchronize the guest operating system with the host. All right, and this is one configuration we have to do. All right, and sometimes, guys, during the installation of the operating system or during the creation of the virtual machine, in a hurry, you configure the wrong operating system and you install the wrong operating system. Suppose what I mean to say is that during the creation of the virtual machine, uh, randomly you go and select the default settings, and the default maybe you have selected Windows 2008 R2 should be get installed on top of your virtual machine, but ultimately you wanted to install XP. So there is a mismatch in what you said and what you installed. So what you're going to do? Again, you're going to recreate a virtual machine and reinstall it? No, not required. There is one setting by which you can make sure that the operating system installed and what you said is absolutely right. How you can do that? Just right click on a virtual machine again, click on edit settings. Okay. Once you click on edit settings, you can go to the options tab again. Under the options tab, guys, you find this option where the guest operating system, Windows, Linux, and other. Suppose let us say here, while we are installing ESXi, during the installation of ESXi, it did not give me the option to select ESXi in other. But after the installation of ESXi, now it gives me the option to select the right operating system. For example, here, VMware ESXi 5.x, you can select the right operating system now and click on open. Suppose it was Windows, and by default you selected Windows Server 2008 R2, but actually you installed is Windows XP. Now you can change it to Windows XP 32-bit or Windows XP, Windows 7, whatever the operating system it may have you. So this way you can change the operating system if you have wrongly configured. Okay. So now from other 64-bit, I can select VMware ESXi 5.x. This VMware ESXi 5.x experimental, this option is available only after the installation of operating system. This is not available prior to the installation. Okay. So in this way, you can change the wrong configuration what you have done. All right. Now let me inform you a few more settings on virtual machines, guys. There is something called memory hot add and CPU hot plug feature. Now, what is the meaning of it is that while your virtual machine is running, you can increase the RAM of your virtual machine's guest operating system, and you can increase the RAM of your virtual machine and add CPU to your virtual machine, which is memory hot add and hot plug feature. Now, this feature is available in vSphere. However, this feature is disabled by default. You need to enable it. Once you enable this, then you can increase the RAM and add CPU to your virtual machine while it is running. However, this depends on two things. First, you need to enable this feature in the settings of the virtual machine. Second, the guest operating system should support the memory hot add and hot plug feature. Now, for example, how to enable this feature? Right click on the virtual machine again, click on edit settings, and here again go to the options tab, and here you find memory or CPU hot plug. Right now it is disabled. You need to click on enable. If you enable this, then you can increase the RAM of this virtual machine while it is running and add CPU to this virtual machine while it is running. However, I told you what is the second thing it depends on. It depends on the operating system. For example, you are running XP on it, then you cannot use this feature. Why? Because XP doesn't support memory hot add and hot plug feature, whereas Windows Server, Enterprise, and Data Center editions will support this feature. So it depends on two things. First, you need to enable this. Second, your operating system needs to also support. All right. And sometimes there might be a requirement for you to power on certain virtual machines automatically when the ESXi host is powered on. So you can configure something called virtual machine startup and shutdown, like automatic startup and shutdown along with the host. Okay. So there might be certain important virtual machines running on the host, and whenever you power on the virtual machine, whenever you power on the ESXi host, the virtual machines will also get powered on automatically if you configure these settings. So for that, you need to go onto the ESXi host on your vSphere client, go to the configuration tab, under the software section, select virtual machines, startup and shutdown. And here right now, this startup and shutdown automatic feature has been disabled. In order to enable it, you need to click on the properties of it. And here you find the option allow virtual machines to start and stop automatically with the system. That means with the ESXi host. Now you need to select the virtual machines which are to be powered on and powered off automatically. Then you need to select the virtual machine and click on move up in this way, and second in this way. Right now, if you see this, I have configured only two virtual machines to automatically start up and shut down. And here, the first virtual machine which is getting powered on would be ESXi-Raj, and the startup delay would be 120 seconds. And after